Okay, what we're working with today is section 2.1, which is writing and graphing inequalities. Okay, so first of all, we need to know what an inequality is. An inequality is a mathematical sentence that compares two expressions. So we have is less than, and less than usually means minus or difference or subtract, but when you throw the word is in front of it, it turns it into an equality, an inequality. This one here that has the line under it is less than, but it equals to, is less than or oops, too many e's, or equal to. And then down here, this one is greater than, same idea. The is turns it into the sign. Greater than usually means that you're adding, but when you throw an is in, that turns it into an inequality. Is greater than. And same thing here, is greater than or equal to. Okay, so what happens is these two, without lines underneath of them, will both be open circles. While these two on the right, which equal it also, means it's going to be a closed circle because it equals that point also. Okay, less than is when numbers get smaller, and numbers get smaller when you go to the left. So for this one, your arrow is going to go to the left. Greater than is when numbers get bigger, and bigger numbers are on the right. So this one, the arrow will go to the right. It's the same case here. Less than also goes to the left. So the arrow will go to the left. And greater than, bigger numbers are on the right, so it goes to the right. So in each box, we're going to try and squeeze in two examples. So here's one, x is less than 3. When I graph these, I'm not super picky. I just do a positive 3 and a negative 3. You do have to show where the arrow goes. So I'm going to graph them two different ways. For this first one, I'm going to graph it on the line. It's an open circle, goes to the left. Now what I do have to do is you have to make that line thick, so you can see it goes to the left, because really number lines should have arrows on them already. Alright, here's another one. This one's going to be backwards. You see that? It looks like a greater than, but x is on the wrong side. So when x is on the wrong side, what some people like to do, they like to rewrite it and flip it so it's easy to see. So I have my number line. Now, if you don't like writing on the number line, then you can write above the number line, but you still need to make the arrow thick. So both of these methods are acceptable for graphing. All right, let's do some over here. So let's try x is less than or equal to 1. And so I'm going to have a closed circle, and I'm going to go to the left. And then same thing, sometimes you're going to have a backwards one. So some people recognize, oh, it's backwards, I have to go the other way. Or they recognize that, oh, it's pointing to x, so that means x is less than 2. They read it backwards. But a lot of people do like to switch it, and it does not take much time to switch it. So now at 2, it's a closed circle, and it goes to the left. So again, you can decide if you like to draw it on the number line or a little bit above the number line. Okay, let's go to greater than. Greater than is the same idea, except this time, instead of going to the left, we're going to go to the right because they're bigger numbers. So I have a 5. Oops, don't color that in, not what I'm doing. Open circle, going to the right. And you see how my arrows overlap the arrows? That's why it's important to make one of your arrows darker. And then let's do -2. Oops, wrong button. Greater than x. X is greater than -2. I just set it backwards. And so I would make this one x is greater than -2. Kind of make this on the line. I'm kind of running out of space. So -2, 2. So it's an open circle going to the right. All right, and then last one, let's do x is greater than or equal to 0. Sometimes you'll have to graph a 0. And so you could put numbers here just to make it so it fills in more. And so it's a closed circle, and this one's going to the right. And then let's do 3 less than or equal to x, which means x is greater than or equal to 3. So closed circle, and x is bigger, so it's going to the right. Okay? All right, so those are the fundamentals of graphing. What I'd like you to do now is let's look at 1 through 4, and I'd like you to try those on your own. And when you think you have it, go ahead and press play so you could check your work. Okay, so at -5, you should have had an open circle, and x was bigger, so it should have went to the right. You don't have to trace it all the way to the right, but it needs to be a big enough arrow. Over here, +2, so it should have been a closed circle at +2. And y was smaller, so you're going to the left. Okay, this one's backwards, so I'm going to rewrite it for us. So x is less than -4, so open circle going to the left. And then here's another backwards one, so I'm going to flip it. So closed circle going to the right at 5. Okay. All right, now let's go to the next two underneath. This time you're writing an equation. So why don't you take a second and try that? Just see if you can get it, and then we'll go. Okay, whenever I do these, I always like to put my x on the left, and I'm comparing it with 1. It goes to the right, so x is greater than, and it's a closed circle, so it's underlined. And then here, again, I like to put my x on the left. Why would you make it backwards and make it more tricky? Always put your x on the left, make it a little easier. With the 1, and it goes to the left, and it's less than, and it's an open circle, so that's all we do. Okay, so let's go up and look at one other type of problem, and this is where we find solutions of an inequality. A solution of an inequality is a number that makes the inequality true. So examples would be 8 is greater than 3. 2 is less than 5. If I ever have anything like -3 is greater than -3, the only way this one would be true is if -3 was greater than or equal to -3. So these are examples of true statements. Okay, so what I do here when I want to determine if they're solutions, I'm going to plug in my value, these different values for x. So here it'll be 2 times 1 plus 1 is greater than 5. 2 times 1 is 2. 3 is greater than 5. No, that's not true. So this is not a solution. Change color so it's easier to see each time. Okay. 2 times 4 plus 1 is greater than 5. Well, that's 8 plus 1. That's a solution because 9 is greater than 5. Okay, one last color. And then let's do this one. 2 times 2 plus 1 is greater than 5. Well, that's 4 plus 1 is greater than 5. And 5 is not bigger than 5. If it was underlined, then it would be okay. But because it's not underlined, it has to be bigger. So this is not a solution. So the only solution for this is B. Okay? All right, let's look at this next one. Now this one has 2 x's, so I have to plug it in twice. So it'll be 2 parentheses 3 plus 2 is less than or equal to -4. So that's 2 times 5 which is 10. 10 is not less than or equal to negative 4, so this one does not work. Okay, let's try another one. Again, I have to plug in my value in twice. Negative 2, 3 plus negative 2 less than or equal to 4. So that's negative 2 times 1 less than or equal to negative 4. And negative 2 is less than or equal to negative 4. That's another one. That's not true. 2 is not less than negative 4. It's actually bigger because it's on the right of it. Okay, last one. Let's try if this one works. So negative 3, 3 plus negative 3 less than or equal to negative 4. So negative 3 times 0 less than or equal to negative 4. So 0 is less than or equal to negative 4. And again, 0 is not smaller than negative 4. So for that one, none of the answers work. Okay? All right, so the big takeaways here is if you have to substitute in, you plug it in. And if it's true, it's a solution. And if it's false, it's not. And then up here, remember, if it's underlined, it's a closed circle. If it's not underlined, it's open. And remember, less than goes to the left and greater than goes to the right.